All right. Remember this setup. Super high tech. Okay. Okay, if it's not, now is the time to put your cell phones away. Okay, put it in your hotel or put it in your backpack. Whatever will distract you. Okay, so this is we're on page 2? Page 2, kind of skip down, and there's a title thing that says periodic trends. Is right where this is starting. There's going to be some kind of blank stuff up before because we just didn't do more examples of configurations that day, but that's all those example blanks were for. So, okay, once again, we kind of talked about this last time, but just to get it down in writing before we do our activity. Okay, the row number, which we also call periods, okay, tells us the energy level of the atom. Or in a sense, how many, use Jacob's lovely atom because it's here, okay, how many rings it has, right? So, for example, strontium is on the 5th row, 5th period, which means strontium has 5 energy levels, or 5 rings. Okay? The valence electrons are the electrons on the outermost ring of an atom. Keep in mind that valence electrons are only the s and the p orbitals. Anyone have a thought of why the d ones don't ever count as valence? If valence is defined as the electrons on the outermost shell, why do the d's never fall in that category? What do you mean by that, Carly?
Because if it falls on the outside, then those ones are like on the outside, and then that D block is like right in the middle. It's not on the outside.
Good. And what does the number, what happens with our number? So this is 4s. What's this one?
SC. Oh, hello.
You good?
421.
So do you remember, so like this is 4s, and then like on your map, what goes this? What is the number?
3D.
3.
Oh,
There you
yeah.
go. So because the D's are always one lower, stuck in the middle like Carly was saying, they're never considered valence because they're not going on the outermost shell, they're going on an inner shell. So if you need to determine how many valence something has, you get its configuration and you just add up, okay, how many S's and how many P's does it add up to? We'll actually learn a shortcut as well so you don't have to write the configuration out. But if you have the configuration, that's an easy way to figure it. Okay, and then another thing that's key is that elements in the same column, so same group, are always going to have very similar configurations, right? For example, hydrogen is 1s1, rubidium is 5s1. And we'll find that there's a significance of them having this same configuration, okay? Okay, so once again, kind of some patterns here. The way that it was organized was this idea, so I'm just going to grab them so I make sure I don't miss something for you. Because he could predict these element properties. Okay, what he did, and this in the beginning, is he started actually quite simple. Is he simply just organized them by mass. He said, okay, this one is the lightest, this one is the heaviest, and put them in order. After putting them in order, he then noticed like, oh, this one, this one, this one, this one, all kind of do this thing. And this one, this one, this one do this thing. And so then he started taking them and putting them in columns as well. So as he read left to right, they were getting heavier, which if we look at our periodic table now, we see is still true mostly. There's always exceptions. And then up and down, he saw similarities of them, which once again is why we call them groups or families. Is because they often behave in similar ways. Okay? And based on the patterns, he was able to predict those missing elements that hadn't ever even been discovered yet. Okay? Another scientist we do need to give credit to, this by the way is a picture of Mendeleev's original periodic table, when he was like still filling things in and stuff. Okay? But another scientist we do need to give credit to is this guy named Henry Moseley in 1913, because of his discovery, he's actually the one who figured out this atomic number, the number of protons in an atom scientifically. Through the use of what's known as X-ray spectrometry, he could identify how many protons are in an element. So it's interesting because to us, a lot of people would look at this periodic table and say, oh, that's probably how they organized it, is by proton number, because it's 1, 2, 3, 4. But that wasn't actually discovered when it was first organized. But once it was discovered, they realized that it pretty much matched, minus a few things that Mendeleev had off. And so then it kind of got rearranged again. The whole theme of this unit is this modern periodic law, is that when elements are ordered by atomic number, okay, when I line them up based on how many protons they have, their chemical and physical properties recur periodically. Once again, periodically meaning like it increases, oh, and then it decreases, and then it increases, then it decreases, right? You see this constant periodic change. Okay, some terms we're going to need for our activity. Okay, we have our blocks, which we've already identified. Okay, so we have the S, P, D, and F block, right? We should be very familiar with those. Okay, a group or family is a column, so anytime you see group or family in a problem or it's talking about that, think up and down. A period is a row, right? So if it's referring to period 6, it's referring to row 6. Okay, these, and it's already printed for you, I think you can read them pretty well. These are the different family names for our groups. Now for the test, there's only 4 of them that you need to either memorize or write down on your note card. Because the other ones I guess there's 5. The other ones we don't talk about that way. We normally just call them by their number. So if you want to put little stars by these family groups, they're like, okay, I need to know this name. You need to know group 1's name, which is the alkali metals. You need to know group 2's name, which is the alkali earth metals. You need to know that this middle section are called the transition metals. And then the 2 other ones are the halogen family, so group 17. And then group 18, the noble gas family. Which once again, the noble gas family is the family that we use to shortcut our configurations. All the other family names, if you look at them, are actually just named after the first element listed. So that's why it's like, they're not weird, it's easy to remember. So, okay, the biggest thing with these families, once again, is they have often similar properties because of those similar electron configurations. Now, we do have some families that are very unique from each other, which I'm sure that just happens in life too, right? You might have a family where you and your siblings are all miniature versions of each other, right? I've taught those families. And then there's other families where you have like no idea that they're even brother and sister, right? So that's how some of these are, right? Group 1, very, very identical, minus 1. Any guess which one is the oddball out of group 1?
Hydrogen.
Hydrogen. Technically, it's not even part of that family. He just hangs out with them, right? But then other ones, so they're very identical, and I'll show you these in a demonstration, so we'll see them and see what they do. But like the halogen family, pretty unique. Keep in mind, remember our color coding system of mine? The red elements are all gases at room temperature. So in the halogen family, we have 2 gases, we have 1 liquid, and we have 2 solids, and then a radioactive man-made one. So very unique in their properties, even though they are the same family. Okay, another property we have is metallic character. It's decently, you want to color in a little bit darker because the way it printed, do you see how like it should be two different colors over here on that little one at the very bottom that's blank, but the one side is all the same color. So if you want to like darken in the purple squares on this one to remind you. Okay, so the other way that the periodic table is organized is that from left to right we change in metallic character. All the elements in yellow up here are classified as metals. And yes, metals are what you would expect them to look like. They're shiny, they're solid. Some of them are hard, some are soft, but kind of familiar with what metals look like. All of the green ones are non-metals. And then these purple ones are classified as a substance known as a metalloid. Metalloids have properties of both. So they're kind of metallic and they're kind of not metallic. For example, silicon, I'll grab a sample and bring it around while we're working. Silicon looks like a metallic rock. So it has the metal side of the shininess, but then it has the non-metal side where it looks like a rock type thing. So based on where something is, this is another thing you can do. So for an easy smiley face today, don't say it out loud, just come up with the answer in your head. Is sulfur a metal, a non-metal, or a metalloid? Don't say it out loud, just find it in your head. Is sulfur a metal, a non-metal, or metalloid? Okay, on the count of three, shout your answer out. Ready? 1, 2, 3.
Non-metal.
You said non-metal, have a smile. But this is what we mean by clues, right? Is to identify an unknown, a clue I could give you is say like, hey, this element is a metal. That clue right away tells you what side of the periodic table should you be looking on. The left side, right? Or left of that staircase element, okay? Okay, I think it's one. Let's see if there's one more I want to do. Okay, we're going to pause there, and I think that's all the definitions we need for the activity page. Okay, go to your assignment packet, and it should be the very next page after the configuration one. I think it says secret agent. Is it the next one, Carly? That one? Yep. Top secret periodic table. Pull that worksheet out for me, everybody. Yeah. Okay, first thing you need to do is the bag I'm giving you has a number on it. You need to write that in the box that says envelope number. Okay. Do you want to work behind that? Does that work? Zach, do you want a buddy or do you want to do it by yourself? Sunjin, do you want to work with Steph behind you? Oh, I gave her that already. And you can let me go. So if you did, over there. So if they're not there, then I might. Okay, open up your bag and pull out all your little funny looking puzzle pieces and spread them out. Face side up so you can see the little camera. First thing we gotta do is make sure you haven't lost any puzzle pieces, otherwise that's gonna make your puzzle very frustrating, right?
One of mine is just.
You should have a blank one, yep, because that's the one you're trying to find. Okay, so spread them all out and count how many little pieces you have. Like little funny looking character guys.
You're at B1 or B5? We don't count this as a puzzle piece, right?
No.
Is this like a puzzle board?
Those are the instructions. No, you gotta build your puzzle to figure out what the missing piece looks like.
Why is it counted in group now?
Okay, everyone have their pieces spread out? Do we count them? How many do we have?
The blank one counts as like one of those you count, right? You're just don't count this one.
Yeah, I had my TAs cut these out last year and they thought it was necessary to give you the heading. But it's not really necessary, so that's why it's there in some of the bags, but it doesn't count as a piece note. But you should have like a piece that doesn't have a guy on it.
Yeah, it says,
That works, yeah, it's either totally blank or it's just not a piece. Okay, how many pieces do we have? 18 is what you should have.
18.
If you don't have 18, let me know, because otherwise you're gonna get stuck. Okay, so here is your objective, everybody. Okay? Your objective is each of these little funny looking alien character guys represents, give your attention here real quick, they represent an element on the periodic table. In terms of, we're only looking at the first 18 elements, obviously, because you only have 18, right? We're not going to build a giant periodic table today. Okay, what you need to do is build a periodic table based on your little character's properties. Okay, now I'm going to give you some hints, and then I'll give you more help as needed. In the end, you should have, after it's built, there should be a missing spot for your blank piece, and it should be organized in such a way that you can draw me a picture of what this guy looks like. Majority of the points for this assignment is finding that missing piece. Okay? Now there's 2 questions at the top I recommend you do before you start putting it together, because it will kind of help get you thinking in what we want. Keep in mind that the periodic table is organized in such a way that when I look up and down, what do I see property-wise? Similar things, right? So things should be similar when you're looking up and down. When I read left to right, what do we see on the periodic table? Different, but like consecutively different, right? Like it's growing or changing in a pattern. Okay? Any questions for now? Okay, let me know if you need help. Ready, set, go.
Alright, first thing they all have a different amount of singles.